For the function 0, 2 pi to r f of x sine 2x minus 3, we need to find f of 0 and f of 2 pi, and then we'll have to sketch the function. So these would be the two endpoints, because that's the domain there. So f of 0 would be equal to sine 2 negative pi on 3, which would be, and we can multiply that 2 in there, it's going to be negative 2 pi on 3, which would, because we go in reverse, 0, pi, negative pi on 2, negative pi, so it's going to be in the third quadrant, and it's the reference angle is pi on 3, so that's going to be negative root 3 over 2. And then f of 2 pi, I dare say, is probably going to be the same answer, but we'll find out. Sine 2 times 2 pi minus pi on 3, which will be equal to 6 pi on 3, take away a pi on 3, makes that 5 pi on 3, multiply it by 2, it's going to make that 10 pi on 3. So 10 pi on 3, which will put that in the third quadrant again if we go round, because that will be 3 pi. Yeah, that'll be the third quadrant again, so it's negative 3 over 2. So we've done that, but now we need to sketch the function, and it's moved over to the right by 3, by pi on 3. So amplitude is 1, thankfully, that's nice. The period is 2 pi over 2, because that's that 2 there, so it gets me pi. It's been moved across by pi on 3. It is a normal sine graph, that's lovely. It starts at pi on 3, and the cycle will end at pi on 3 plus pi, which will make that 4 pi on 3. And then the halfway point, which would have been pi on 2, pi on 3 plus pi on 2. So pi on 3 plus pi on 2 is going to make that, I think, from memory, 2 in Schmer. Yeah, it's 5 pi on 6. And then halfway to that, so pi on 3 plus pi on 4. This is where we're going to get our 12s again. So this is going to be 4 pi plus 3 plus, that's a 7 pi on 12. And then we will go and do 5 pi on 6 plus pi on 4. So 10 pi on 12 plus 3 pi, that's a 13 pi on 12. So that's for one cycle, and that gets us to 4 pi on 3, but we'll need to draw all the way to 2 pi. So just so you're aware that what the shape would look like so far, it will look like this. So we can go another halfway, so where will that end up? 5 pi on 6, or 4 pi on 3 plus another pi on 2. So 4 pi on 3 plus another pi on 2 is going to make that 6's plus 6's. So that's going to be 6 pi, no, it's 3 pi, and that's going to be 8 pi, so that's going to become 8 pi plus 11 pi on 6. It's going to be, it's going to be 11 pi on 6. And I know that 12 pi on 6 is going to be 2 pi, so that means it will end just about under here at 2 pi. So, hooray, that's lovely. And then 7 pi on 12, so that's going to be the same as 3.5 over 6, so that's going to be here, so that's 1, negative 1, so it's going to be about there, and then 5 pi on 6, and then 13 pi on 12 is going to be 6.5 over 6, yes, so 6.5 over 6, which is about there. and then it will return back to 4 pi on 3, which is 8 pi on 6. And then let's continue that pattern going. So that's going to be there. It's going to be here. And then it'll end about here. There. So it should... So again, we'll put in our endpoints. So we've got, this will be 2 pi negative root 3 over 2. This is 0 negative root 3 over 2. This is this is pi on 3. 0. This is 7 pi on 12. 1. This is 5 pi on 6, 0. This is 13 pi on 12, negative 1. This would be 9, 9.5. Makes that what? 9.5, double that. 19 pi on 12, 1. And that's 11 pi on 6, 0. And there is our graph.